In this tutorial, I will show you how to use Excel to do the Holt-Winter technique for forecasting trended and seasonal data. Here I have the gap sales data from March 1985 until March 2007. Let's first visualize the data. Here on the screen you can see the graph of the sales data. When you look at the graph, we can see there is a continuous trend going upwards, and we can see there are ups and downs that repeat every 4 quarters. If we just use the Holt's method here, we would forecast sales numbers on the trend line. So let's say you forecast sales here by using Holt's method, because Holt's method only utilized from the trend line to forecast sales. The trend line might forecast quarter 1 sales very close, but when it comes to quarter 4, as you realize that, it will underestimate the sales. Instead, if we use Holt-Winter techniques, that will capture both trend and seasonality and estimate both the seasonality and the trend of this data. So let's see how we can do Winter's method with 4 quarters or 4 seasonal indices in the following workbook. To get started, we have to have initial numbers for the level, trend, and seasonality. So as you realize, Winter's method has 3 components. The first one is the level forecast, the second one is the trend, and the third one is seasonality. So we have to have initial numbers for the level, which is forecast level, trend, and seasonality. We are going to use the first 4 periods to initiate our data. That's I'm going to just take the average of first 4 periods of actual sales, and I'm going to find this average right here, seasonal average. The average of 4 periods comes out to be 161,833, and I will use this number to estimate seasonality index for the first 4 periods. To do so, I'm going to divide actual sales in period 1 by our average over the 4 periods. Actual sales in period 1 divided by seasonal average. And I will do that for the second season or quarter 2, actual sales in quarter 2 divided by seasonal average. And I will do for third quarter, and then I will do that for the fourth quarter. Now we have found the seasonality indices, which are 0.65, 0.74, 1.12, and 1.48 for 4 quarters. Let's try to understand what 0.65 stands for. Basically, the sales in quarter 1, or March 1985, is 35% lower than the average sales in a year. As you realize, March 1985 is a low sales season. The second quarter sales are 26% lower than average sales. On the other hand, the third quarter sales are 12% higher than average. It's a high sales season. And fourth quarter is 48% higher. As you realize, the highest sales are always in quarter 4 and lowest are in quarter 1. Next, we need the initial value for the forecast without trend and seasonality. Just for lack of a better option, I'm going to use the average of first 4 periods as the March forecast or level, which I have never estimated. And I will use number 3 for the trend estimate. I choose 3 since the first period trend will be 0, second will be 1, third will be 2, and fourth will be 3. I want you to understand one important point here. I guess initial values for the numbers I have not estimated. However, for the estimates of level, trend, and seasonality in the following periods, we have to apply 3 different formulas to get estimates. We start with our estimate for the level. We have 3 smoothing constants here. Alpha is for the level, beta is for the trend, and gamma is for the seasonality. Just be careful, I randomly assign these numbers. We will learn at the end of this video how to find optimal constants for the data given using Excel solver. Let's check the formula for the level. In the formula, I fix the alpha so that when I copy down the formula, the alpha is always the same number. In addition to that, if we want to adjust for alpha, we can just adjust the cell, and this adjustment carries over to all calculations. So level is equal to alpha times sales at time t. We are in period 5 or March 1986. Therefore, I'm going to use actual sales in March 1986 divided by our seasonality index estimate in period t minus p. So we know our season is 4 periods long. Therefore, p is going to be 4. And we are in period 5. 1, 2, 3, 4, 5. So 5 minus 4 equals 1. You might think this as, since we are forecasting the data for the first quarter, we will use the first quarter's seasonal index of the previous year, plus 1 minus alpha, also I fixed that cell, times level at period t minus 1, which is the last period's forecast of 161,833 we just estimated, plus the trend at t minus 1, which is the last period's trend estimate of 3 we just guessed. This is all we need to do to calculate level. Trend is calculated by taking our coefficient beta times level forecast in this period minus level forecast in the last period, which is 186,753 minus 161,833, plus 1 minus beta multiplied with a prior trend estimate of 3. That's all we need to do to calculate trends. Next, we are going to update of the seasonality index that is calculated by our coefficient gamma times actual sales in this period, I have some parentheses here, divided by level forecast in this period, plus 1 minus gamma multiplied by the estimate for seasonality at t minus p, t equals 5, in this case p is 4, so we take our first seasonal index estimate, which is 0.65. So you might think that since we are forecasting a sales number for the first quarter, I should use the seasonal index that we have found for the first quarter of the previous year. This is all we need to do to calculate the update of the seasonality index. Next, what we will do is we will put together our forecast. Now our forecast at time t plus m depends on this coefficient m, and m is how many periods ahead we forecast. In this case, we are going to keep m equal to 1, so we are forecasting for 1 period ahead. Therefore, since we are forecasting FITS t plus 1, we will use the level at time t, which is 161,833. We have to go back 1 period. Then we add m, which is 1 times the trend at t, and trend at t is 3. This sum is multiplied with the seasonality index of quarter 1 of the previous year. So that is our forecast including trend and seasonality. In fact, we need previous period initial values to update the trend. However, we have to go through 1 full season of initial values to update the seasonality index. Let's check our graph. Here the blue line is the actual data, and the orange line is the forecast that we find using Winter's method. Our forecast matches the actual sales quite well. I mean, it follows the general trends. However, we can still improve on this forecast by adjusting alpha, beta, and gamma. As you remember, we assigned random values to alpha, beta, and gamma. In this case, the best way to adjust these smoothing constants, we will use Excel solver. And I will show you real quick how to use solver. First, click on the second workbook that includes calculations of error statistics. I copy here all the formulas that I have calculated in the previous workbook. Then I have calculated errors, and then I calculated squared errors, and then I find mean square error, and then finally I calculated the root mean square error. Here, the root mean square error is 1,180,642. And I use alpha 0.3, beta 0.3, gamma 0.3 to calculate these root mean square error. Now, I will show you how to use solver to find the optimal constants that in fact minimizes the root mean square error. So you click here on data. under Data, on top of the Data Analysis, there is Solver tab. Click on Solver tab. Solver asks you to set an objective. In this case, my objective is to minimize root mean square error. Here the idea is we want to make the minimum error by changing the constants. And you can pick any other statistics that you wish, but since we are using root mean square error for all our assignments, we are going to minimize root mean square error. I want to minimize the root mean square error statistics by changing the variable cells M4 through M6. These are the cells that in fact have the random values for alpha, beta, and gamma. So there is our alpha, beta, and gamma subject to the constraint that each one of these is not smaller than 0 and is not larger than 1. Because I don't want the computer to find alpha, beta, gamma that is greater than 1 or smaller than 0, I have to set up these constraints. After I enter the constraints, I hit Solve. Then the computer is going to ask us to keep solver solution. You will click OK. And the computer program will calculate different values for alpha, beta, and gamma. And it will pick the ones that give us a minimum value for root mean square error statistics. As you remember, it was 1 million something before. Now it drops down to 483,218. So that will make our error lowest as possible given the constraints that we have chosen here. So what I'm going to do, I'm going to copy down this alpha, beta and plug here. And now as you see, our forecast is going to adjust to the new alpha, beta, and gamma. One final point I'm going to explain today is using Winter's technique for out-of-sample forecasts. So for your project, you need to forecast sales data for a period that you don't have the actual sales. So what we are going to do here, we are going to use the same equation, but a couple of minor adjustments for that equation. Let's say we want to forecast for 1st June 2007. Here, since we are forecasting one period ahead, M is going to be 1. And I'm going to use level forecasts for March 2007 and trend forecast for March 2007. And I'm using the seasonal index of second quarter for 2006 since I'm forecasting the second quarter sales data for 2007. And one important point here is that I fixed the value for level and trend since I'm going to always refer to level and trend of March 2007 when I forecast for out of sample. Let's see here. And now we are forecasting for September 2007. So I'm going to use the seasonal index of September 2006, which is for third quarter. And I'm still going to use the level forecast of March 2007 and trend forecast of March 2007. But I'm going to adjust M to 2 because now I'm forecasting 2 period ahead. And now it will continue like that for 2007 December. As you realize, I'm still referring to the level forecast of March 2007 and trend forecast of 2007. But now I'm forecasting 3 periods ahead, so I'm going to adjust M to 3. And I'm going to use a seasonal index of the fourth quarter of 2006. So let's check one more data here. Here, I'm going to use M as 6 because now I'm forecasting 6 periods ahead. If you count down 1, 2, 3, 4, 5, 6, that's why M is going to be 6. Still, I'm referring to level forecast of March 2007 and trend forecast of 2007. And here, the seasonal index I'm going to use is the third quarter of 2006. Because I'm forecasting third quarter of 2008, I'm going to use the seasonal index of September 2006. That's all. This is how we apply the Holt-Winter technique for exponential smoothing.